Right. This is a quick review of our 2.1 through 2.4 sections, which is our functions, function notation, and properties. So let's look at this first example. Is this a function? Well, if I do the vertical line test and I put a bunch of vertical lines, notice no line hits more than 1 point, so therefore it is a function. Okay, I'm going to go ahead and erase my line so we can see. Now it wants me to evaluate f of -1, which means x equals -1, and I'm looking for my output. So I'm going to go up to -1, and I'm going to go till I hit the graph, and my height is 2, therefore the answer is 2. Domain. So my graph starts here and it ends here. Please note that this was an open circle. So I'm going to use a parenthesis, and it started at -4 and it goes to 5. And because 5 is a closed circle, I'm going to use a bracket. Now I'm going to look at the range. So I'm going to go from the floor, the lowest, which is 2, and it's going to go all the way to a height of 5, but 5 is not included because it is an open circle. Okay, next problem. Is this a function? So each x points to exactly one y. It's not going to multiple y's, so that is correct. That is a function. 3, when x equals 3, let's see, when x equals 3, it's pointing to the number -2, so the answer is -2. My domain is all my x's, so my domain is going to be squiggly bracket -3, comma, -2, comma, 2, comma, 3, my other squiggly bracket, and my range is going to be squiggly bracket -2, comma, 6, squiggly bracket. Sorry, my brackets aren't that pretty. Okay, so next. Is this a function? Well, when I do my vertical line test, I hit more than 1 point, so therefore it is not a function. It's not one-to-one. Each x does not just go to one y. When I evaluate f of 12, it's going to be 4, and it's also going to be -4. That's also how I know it's not a function, because there are two outputs at 12. So 4 and -4. I guess I should really say -4 and 4. Should start low to high. Okay, my domain is going to be -4. It starts here at -4 and goes on to infinity. So I can put a wall here, but I can't put a wall on this side. So -4 to infinity. And my range is, it keeps going and going both directions. So the basement is -4 and the ceiling is, sorry, the basement is -infinity and the ceiling is infinity. All right, one more of these. Is it a function? So I'm going to look at each of my x's. Okay, so far 1, 0, 2, oh, 0. Oh no, it is not a function because 0 repeats. So no, 0 repeats. So it's not one-to-one. So it's a relation and not a function. Repeats. Sorry, sloppy. Repeats. Okay, evaluate f of 2. So when the input is 2, the only output is 0. And my domain, I'm going to do my squiggly bracket, and I'm going to list out all my x's. So my lowest x is 0, then I have 1, then I have 2, and then I have 3. I'm just listing out each of the unique ones. You could list all of them out, and then you would see that the 0 repeats. Therefore, again, it's not a function. My range is going to be 0, 1, 2, and 3 as well. Okay, so my y's can repeat, but my x's cannot. All right, next set of problems. Okay, so this is function notation, and this one right here is saying look at function f, so that's this one, and replace x. So x is going to be -3. So I'm going to go ahead and type this one because it'll probably go a little bit faster. Let's pick a prettier color. Here we go. So, and we're going to increase the font size 60. So I'm going to do -8, plugging it in using parentheses, -3 plus 7. So -8 times -3 is +24 plus 7 equals 31. Okay, g of 0. This time I'm going to use this function, and I'm just going to plug it in. So 2, plug in 0 squared, okay, and then I'm going to subtract 5. So 2 times 0 squared is 0, minus 5, and 2 times 0 is 0, and 0 minus 5 is -5. All right, the next one, f of 10. So f of 10 is going to be -8 times 10 plus 7, which is -80, plus 7, which equals -73. And the last one, function g, is going to be 2. Replace it with 6. They want us to square it. And then we're going to subtract 5. So it's going to be 2 times 6 is 36, minus 5. 2 times 36 is 72, minus 5 is 67. Okay, what this review did not have, and let me just do one of these, is let's say I had instead said f of x equals, let me pick a number that's going to work. Let's pick, sorry, 39. Okay, so in this case, I would do -8x plus 7 equals 39. Okay, sorry guys, it got interrupted, so I'm going to, hopefully this got pieced into one video. We will see. Okay, so what I'm going to do right here is I'm going to add 7 to both sides. In this case, in this notation here, I'm replacing the output and solving for the input. Okay, so, oh, sorry, not add 7. I want to undo, so I'm going to subtract 7. What I do to one side, I do to the other. So now I have -8x equals 32. I want to separate the coefficient from the variable, so I'm going to divide by -8 on both sides, and I end up with x equals -4. Okay, so when it's in parentheses, that's the value of x, and you're replacing x and you're simplifying. When it's not in parentheses, that's your output, and you're replacing the output and solving for x. All right, let's look at our properties. Okay, domain. Domain is my input, all my x's. So when I look at this graph, x is going to go from -infinity. Okay, there's a break right here. So I have a break at 4, and then it's going to continue on to infinity. Okay, so my function is going to be, domain is going to be -infinity up to 4. Now, when I travel the graph, I'm traveling. At this 4, it's closed. So it's going to get a bracket, and then change, make a jump, move on, and then I'm going to pick up at 4, but this time this 4 is open, and I'm going to continue with my graph all the way to infinity. So now I need to partner up. So at -infinity, my range is -infinity. Again, kind of looking at those end behaviors. Okay, and then when I get up here to 4, my output is 4. Right here, my output is 4. Okay, and then I'm going to make a jump, and at this 4, I'm at 6, but it's a parenthesis, okay? It's a parenthesis because it doesn't include it. It's an open circle. And then it's going to go and stay at 6. And it's going to equal 6. So I'm going to go ahead and put a bracket. Is this continuous? No, it's discontinuous because of this break right here. My x-intercept, it hits the x-axis at 0. It hits the y-axis at 0. Bounded, it's bounded at the top because if I look at the beginning of my range, it's negative infinity, the n is 6. So I don't have a min, but I have a max. So it's bounded by the max, which is above, the above part. So this gets above, it's bounded above, okay? If I know the max and the min, it's bounded both. Remember, max goes with above, min goes with below. So my max is 6, but my min is 9. To determine, right now, we're only looking at graphs. We're not doing it algebraically. So to determine even, odd, or neither, we're looking for symmetry. And there's no symmetry to this graph, so it's going to be neither. All right. My increasing interval is from negative infinity all the way until I get to 4. Hold on, I'm increasing. It's from negative infinity to 4. And then I know it keeps going on, but it's constant. So the decreasing is none. And my constant interval, okay, it's going to be constant right here at 4 all the way to positive infinity. So that's going to be constant. Sorry for my handwriting on the screen. So it's constant. I'm just going to abbreviate. So it's constant from 4 to infinity. Hope this helps you review.